Now let's redo the exact same problem using rejection regions. Again, we're going to do the same thing. We'll set up our claim, which is our claim was that the mean was, let's see, the claim is that the mean body temperature is equal to 98.6, which would put our mean equaling 98.6 as our H naught because of the equal to symbol. That means H1 would be the complement, which is mu is not equal to 98.6. Everything else is going to be the same. We're still going to be doing a z-test. We still have the same exact information. We still have that what we're testing for the null is the 98.6. They still gave us the population standard deviation of 0.62. They still give us the sample mean of 98.2 and still gave us a sample size of 106. And we're still testing this using a two-tailed test because of the not equal to and our alternative hypothesis. We'll have our calculator go ahead and calculate. But if we're going to use rejection regions, I don't care about the P this time. I care about the Z value. Again, this is what's called my test statistic. It's the thing I'm going to test when I come up with my rejection region to see does it fall in the rejection region or not. So if I round this out to 2 decimal places, our test statistic is a Z value of negative 6.64. So let's figure out what our rejection region is. Well, to figure out what our rejection region is, we draw the picture. Well, because of the not equal to and my alternative hypothesis, that tells me that I'm looking at a two-tailed picture. How do I figure in the area of the two tails? Well, I'm going to use the alpha, which in this problem was 0.05, but I have two tails, so I have to split up that alpha, that 0.05, between both tails, which means that each tail individually will actually be half of that, 0.025. Well, after I have the 0.025, the question is, how do I find the Z values that make up these two sides of my rejection region picture that I have? Well, remember, if I'm looking for Z values, I'm going to use the inverse norm function of our calculator, but we're not going to do it on 0.05. We had two tails, so we had to cut it in half. We're actually going to do it on half of that, which is 0.025. I only actually need to find one of the two tails because remember, the normal curve is symmetric. So whatever value I get for this lower end on that side of the rejection region, the upper end will be the same, just positive. So what we find out is if we do inverse norm of the 0.025, we get a Z value of negative 1.96. So that means the left side of my rejection region ends at actually negative 1.96, and the right side of my rejection region starts at positive 1.96 because of the symmetry. Next, the question becomes, where does our test statistic fall in this rejection region we just came up with? Well, the value that we got from our calculator for the test statistic was a negative 6.64. Putting that into our rejection region that we just came up with of negative 1.96 and starting out with 1.96, notice clearly your test statistic is right in the middle of your rejection region. Because it is, that means we're going to reject H naught. The question is, what does that mean? Well, let's remind ourselves what H naught was. H naught was our claim that the mean was 98.6. This was our claim also. Now, I don't need to write out H1. We only care about H naught because it was our claim, which we're going ahead and rejecting. So, just like before, what this means is that we are going to reject H naught. Because we're actually doing something, there is sufficient evidence to do what? Well, we are rejecting the claim that the mean was equal to 98.6. And we're done. Again, if they actually ask what's the rejection region, well, the rejection region was anything below negative 1.96 and anything above positive 1.96. These two values, negative 1.96 and 1.96, they make up our rejection region. Another fancy name for them are your critical values.